Hey everyone, welcome back to day 2 of operations of complex numbers. Today we are just going to focus on dividing complex numbers. Okay, and this is in your Springboard book on page 129. It would start, and you'll want a pen or a pencil and your calculator as well. Okay, the good news is, as long as you really understood how to multiply, then you should be okay. Those are the basic skills that we're going to need when we are dividing complex numbers. Okay, so first thing here, it says that it's talking about a complex conjugate, and we're actually going to need that in order to divide. So it says the complex conjugate of a plus bi is defined as a minus bi. For example, the complex conjugate of 2 plus 3i is 2 minus 3i. So you can see that here, that the only thing that really changes is the sign between a and bi, okay? So it says between the real and the imaginary terms, right? So it says for number 12, a special property of multiplication of complex numbers occurs when a number is multiplied by its conjugate. Multiply each number by its conjugate and then describe the product when a number is multiplied by its conjugate. Okay, so first of all, let's write what these conjugates should be. So if we have 2 minus 9i here, the conjugate would be 2 plus 9i. And that's all we have to do is change the sign in the middle. Okay, same thing. If we have negative 5 plus 2i, the conjugate is negative 5 minus 2i. Okay, so again, noticing negative 5, negative 5. The real number did not change. 2i, 2i. The imaginary number did not change, just that sign in the middle. Okay, so it went from a plus to a minus. Okay, so let's just go ahead and multiply one of these so that I can show you guys what happens when you multiply a complex number by its complex conjugate. So let's go ahead and do this one. So we have 2 minus 9i times 2 plus 9i. Okay, so if we were to multiply these using, let's say, FOIL, we would do our firsts. 2 times 2 is 4. Then we would do our outers. 2 times 9i is 18i. Then we would do our inners. Negative 9i times 2 is negative 18i. And then we would do our lasts. Negative 9i times 9i is negative 81i squared. The nice part about multiplying a complex number by its conjugate is that these middle numbers are going to cancel. We have positive 18i and negative 18i, so those cancel. Okay, so then we're left with 4 plus negative 81i squared, which remember, for I squared, we're going to plug in negative 1. So really, negative 81 times negative 1 becomes a positive 81. So then we just add those two together and we get 85. So that is the whole point of a complex number being multiplied by its conjugate, is that it results in a real number. As you can see, we got 85. And the product is just the sum of the squares of a and b. So if you were to just square your a term, which is 2, 2 squared is 4. And if you were to just square your b term, which is 9, so 9 squared is 81, then you would have gotten that 85. So that's a shortcut if you want to use it. Or another way to just think of your shortcut would be to, just realize that those middle terms are going to cancel out. So then you could just really do, when you're foiling, you can just do the firsts and the lasts. You don't have to do the outers or the inners because those are always going to cancel as long as you are multiplying by the complex conjugate. Okay, so let's go ahead and use that now, moving forward here. So it says to divide two complex numbers, start by multiplying both the dividend and the divisor by the conjugate of the divisor. Okay, so basically what that means is you need to take the denominator here and find the complex conjugate, and multiply the top and bottom by that. Okay, the reason we do this is because remember, we cannot have a radical in the denominator, so we also can't have that I in the denominator. So the reason we do this is now because if we multiply the denominator by its complex conjugate, those I values are going to cancel and leave us with just a real number in the denominator. So that's what we want. Okay, so as you can see, step 1 is to identify the complex conjugate of the denominator, and they did that here. So the conjugate of 2 plus 3i is 2 minus 3i. Then you are going to multiply that by the top and the bottom, because remember, whatever you do the bottom, you got to do the top, okay? And technically, if you write something over itself, it's basically like you're just multiplying by 1. So that's why this is mathematically legal, okay? So then we go ahead and we multiply, and basically we're just rationalizing. And you can FOIL or box method, and that's what they did here. And then you're just going to go ahead and combine like terms and replace any I squareds with -1. So that's what they did here. And then your last step is that you're going to rewrite it in the form a plus bi. So we're going to separate it into 2 fractions and write it as a plus bi. So basically you just take this and put it over 13, and then take this and put it over 13, the denominator. Okay, and that's how they got this final answer here of -7 over 13 minus 22 over 13i. And now it's in that form, a plus bi for a complex number. Okay, so let's go ahead and try a couple. So we're going to go ahead and try just B and C on that next page. So on page 130 in your Springboard book. I'm going to go ahead and move to another page just so we have room. And if you want a separate sheet of paper, you could do that as well. Okay, so for part B, we have 5i over 2 plus 3i. So again, remember, your first step is to find the complex conjugate of 2 plus 3i, the denominator. So the complex conjugate of 2 plus 3i is 2 minus 3i. And so we're going to multiply by this on the top and the bottom. Okay, so now let's go ahead, and actually the top is not bad because we can just distribute that 5i. So we get 5i times 2, which is 10i. And we get 5i times -3i, which is -15i squared. And I will come back and kind of simplify, combine like terms, and plug in -1 for I squared in a second. Okay. Then on the bottom, unfortunately, we are going to have to FOIL here. But remember, these are complex conjugates. So if I FOIL, those middle 2 terms should cancel. So 2 times 2 is 4. 2, those are my firsts. Then my outers, 2 times -3i is -6i. Then my inners, 3i times 2 is +6i. And then my last, so 3i times -3i is -9i squared. Okay, and again, if you wanted to skip the O and the I, meaning the middle 2 terms there, you could, because remember, those cancel. Okay, so now let's go ahead and simplify and plug in -1 for our I squareds. So -1 there and a -1 there. And so we're going to get 10i minus 15 times -1. So that's going to be 10i plus 15. And then on the bottom, we're going to end up with 4 minus 9 times -1, so 4 plus 9, which is 13. And then the nice part is we no longer have an I in the denominator, so we know we're almost done. Just the last step we're going to do is put it in that A plus BI form. So, and we're going to put it into fractions. So the 15, let me change colors here. Let's do this 15 over 13. That's going to be the real part. So that's your A. And then plus 10I over 13, that's going to be your B. And that's it. So this is your final answer now, and it's written in A plus BI form. Okay. All right. Cool. So then let's go ahead and try another. And here we have 5 plus 2I over 3 minus 4I. Okay, so remember, first thing you need to do is find the complex conjugate of your denominator. So the conjugate here that we're going to multiply by, if we have 3 minus 4I, the conjugate is 3 plus 4I. We're going to multiply that by the top and the bottom. Okay, so on the top, you're going to have to FOIL this time. So let's go ahead and do that, or box method. So 5 times 3 is 15. That's my first. My outers, 5 times 4I, so 20I. My inners, 2I times 3, so 6I. And my last 2I times 4I, so 8I squared. And we'll come back and clean that up in a second. Okay. Then we need to go ahead and do the denominator, and I'm going to use a little shortcut here. I'm going to do just my firsts and my lasts. So first is 3 times 3, which is 9. And then your lasts are going to be negative 4I times 4I. Okay, so that's going to be negative 16, I squared. Okay, so notice I just skipped the outers and the inners because those were going to cancel. Those were going to be 12I and negative 12I. Those were going to cancel anyways. Okay, so now let's go ahead and simplify. This would be 15 plus 20I, and 6I is going to be 26I. And then 8I, okay, here's where we need to plug 8I squared. We need to plug in that negative 1. So 8 times negative 1 is a negative 8, and we'll simplify that in a second. And then this, we're going to plug in negative 1 here. So 9 minus 16 times negative 1 is going to be 9 plus 16, which is going to give us 25. Okay, so then we just need to combine this 15 and negative 8. So that's going to give us 7 plus 26I over 25. So now we're in simplest form. We have no more i's in the denominator. So I'm just going to split this up. 7 over 25 plus 26I over 25. And notice all I'm doing is basically splitting up the numerator into two separate ones and putting them both over the same denominator. Okay, so this right here would be your final answer. 7 over 25 plus 26I over 25. Okay, so that right there is division. Again, you're going to follow these steps every time, and really, as long as you know how to multiply well, then you will be good to go. And as long as you remember to plug in your negative 1 for I squared and simplify and put things in A plus BI form, then you are good to go. Okay, so that's pretty much it today. If you guys have any questions, we will be doing some more examples in class tomorrow. Have a good one. Bye-bye.